This is the Rubenstein Lab, built in 1998 as a state-of-the-art research lab and educational facility focused on the Lake Champlain watershed. Although this building is LEED certified and relatively new, it has a very high energy demand.
This graph shows the energy usage of the lab, which we noticed was higher than any other similar lab on campus.
Our goal as Greening of Aiken interns this semester was to perform an energy audit to investigate the energy use of the Rubenstein Lab and identify opportunities to save energy. This is an important step towards a greener UVM.
This is the fridge and freezer used for the lab. They are known energy hogs, but they're an essential part of the lab. One thing we're going to do is put more efficient light bulbs inside of them, as well as recommend installing a free air system, which uses cool air from outside during the winter instead of refrigerating warm inside air. This is another essential piece of equipment for the lab. That's an energy hog. It's a reverse osmosis machine, which is used to treat the water for lab experiments. The current model is 15 years old, and it's a single-speed motor that's almost constantly running. We recommend installing a newer model that is a variable speed motor and won't use as much energy. An old refrigerator, which are known energy hogs. If we upgrade the model, Burlington Electric offers rebates.
So this is a kilowatt meter often used for plug load analyses. Appliances and other technology use energy even when they're off and plugged in. This is called a ghost load. So this is the main printer and fax machine utilized by the office. When it's on and not in full use, it uses 250 to 300 watts. In between sessions with this printer, the office can turn it into energy saver mode, which uses only about 70 watts. And then at the end of the day or on the weekends, we recommend using a timer to turn the printer off, as its ghost load is about 18 watts. This building has incorporated some passive solar design with ample natural lighting coming in. Even on a beautiful sunny day like this, hallway lights are on. When I turn them off, it doesn't make a remarkable difference, so this would be a great opportunity for daylight sensors.
So I just walked into the stairway, and as you already see, there are lights currently on. This is a big waste of electricity, and an easy way to cut down this would be to include occupancy sensors, which would turn on only when someone walks into the stairwell. Right now we are in a standard lab, and in this lab there are 7 fixtures of 32 watt CFLs. In the future we are upgrading these CFLs to 11 watt LEDs, which will save a lot of energy.
So these are 2 large buckets that are used in aquatic lab experiments. Right now they're keeping sea lamprey in there, which need to be kept at a pretty cool temperature. But unfortunately the insulation of these buckets is not very good, so it's taking a lot of energy to regulate the temperature. So we recommend getting better insulated bins and other lab equipment to hopefully cut down on the energy use in this lab. So as pointed out to us by staff and our own observations, we noticed that light switches in this building aren't conveniently placed. As you'll notice, there's none by this door as you're leaving the lab, which despite good intentions often discourages faculty from turning the lights off as they leave.
From changing lighting alone, we can reduce usage from 13.7 kilowatts to 4.9 kilowatts by using LEDs instead of CFLs.
Using data from our plug load analysis, we learned that by replacing the old fridge, installing timers, and unplugging unused equipment, we could save 4.9 kilowatt hours per day, 1,790 kilowatts per year, and over $250 per year.
We hope future Greening of Aiken interns can utilize our wiki space using data we've collected to kick energy conservation into high gear.
Being part of creating a greener campus is something we can all celebrate.